So we've made it to that urine formation 1, where we have had the blood flow into the kidneys. We have made it through those arterioles into this nephron, and that's going to be too distracting to me. My ADD's going to kick in. Sorry. Like I can't concentrate. All right, so we've made it to the nephron, and we have gotten into this glomerular capsule. We've discussed the flow that comes in, like for males, the 180 liters per day. Females, I think, was 150, okay? And so at the point where we are in that nephron, all right, so let's see. And then we got the two, you guys got the idea, right? Okay, so we're in this glomerular capsule, and we've got the blood that came in under high pressure, and then all the stuff gets pushed out. And so this was the point of the urine formation 1. Well, now at this formation 2, the second stage to form urine, we're going to get to tubular reabsorption. Now remember, we mentioned reabsorption because we've already absorbed the substances once. We are now going to reabsorb them again, because when that blood got pushed through that glomerular capsule, lots of things were pushed into that filtrate that got formed. We had electrolytes, we had glucoses, we had the nitrogen waste, we had a lot of things that got pushed into that filtrate. Some of it we need to return. So now we have got to see materials go back to the body. For the tubular reabsorption, we're going to be in the proximal convoluted tubule. The first exit, well, the only exit, the first curly coily tubes that exit off of this glomerular capsule. The structure, the cells that are going to make up that proximal convoluted tubule, the cells contain prominent microvilli. The cellular structure is one that is good for movement of materials. All right? The routes that we can take. Do you guys remember me drawing the cells? Okay, some of them having the microvilli, and we talked about how these cells are together. Okay, the two routes, transcellular. What does trans mean? Trans means to go across. For example, a transatlantic flight is to go across the Atlantic. Okay? Transcellular, across the cell. All right? So that means materials will move across the cell. Paracellular. Para means what? Or around. Okay? Between or around. Materials are going to move through, or between the cells. Okay, is everybody following me? We have something called solvent drag. This means there are some substances that move by one of these routes simply because another substance is moving. That's it. They get to move simply because another one is moving. So at this point, we are going to return about 65% of those solutes. So here's what we're looking at. If this is the interior, now, let's say that this is my PCT, my proximal convoluted tube. And that's simply what it is. It's a tube. Tubes have a lumen. Lumen being the space. Okay? So that tells me that the filtrate from that capsule is now going to move this direction. Now, do you happen to remember that we have those two types of nephrons? One of them will have the capillaries surrounding this tube. One of them will have the capillaries surrounding the loop. 85% of the nephrons have the capillaries surrounding this tube. Now, what's that going to tell me? That means if I'm looking at my proximal convoluted tubule and based on 85% of the nephrons, I've got a blood vessel that's in close relationship to this tube. Now, materials are going to be able to move out, and at the point where they get to move out and go back to the tissues, i.e. blood vessels, for example, okay, this is the point they're reabsorbed. Okay? Because absorption is coming through here. And if we move them back out to get them back to the body, we have reabsorbed them. If I have materials that are still moving through my blood vessel, but I need to get them out and back into the tube, they've been absorbed here once already. And if I can move them from the blood into the tube, they've been reabsorbed into the tube. Does that make sense? So now, this reabsorption that's going to occur in the filtrate that's now passing through here, one of the electrolytes that's very important to us, sodium chloride, okay, we don't need that to go, all right? We need that to stay in the body. So at this point of the urine formation in the proximal convoluted tubule, it is a key element that we're dealing with. So the sodium chloride is very high in this filtrate. Do you happen to remember what it means to be either the apical surface or the basal surface of a cell? Top or the bottom. So this surface that's facing the lumen of the tube, this is my apical surface. The one that'll be down here near the membrane, this is my basal surface. Okay, so the apical surface has, ta-da, transport proteins. Where do I find those? In my plasma membrane. So all throughout this plasma membrane, on this apical surface, I'm finding transport proteins. How do transport proteins work? Now, if they were voltage gated, yes. But do we have other types of transport proteins? Yes. We have the ones that if something fits the shape of it, it'll pass through, okay? If we have some that are freely open, that allow stuff to pass through. So we've got these transport proteins that are present. So these transport proteins, they can function by being a SYM port. Symbiotic, okay, together. So that tells me sodium can move with another substance, okay, like the drag, okay, that solvent drag. An anti-port, anti means what? Against. So that tells me if I have a transport protein, now this one, if it's dealing with the hydrogen ions, okay, the hydrogen ions, if they're moving in one direction, they allow sodium to move in the other. Sodium, potassium pumps. This would require energy. It would be the one that needs to equal out the sodiums and the potassiums across that plasma membrane. All of these are working to move the sodium back to the body where we're going to need it. The other electrolytes, potassium, magnesium, phosphate, okay, where have we heard of those from? Just about everything, okay? They're being used in the bone, in the muscle, in the nervous system, in the blood, you name it. They're being used, okay? These go through paracellular routes. So they simply get to move between the cell. Why did they get to move so easily? We're going to be working in water, and it's going to help us get water back to the body, and therefore help reduce that filtrate, which is 180 liters per day, okay, but that 125 milliliters per minute, is that right? Somebody tell me if I don't remember my numbers, okay? But that 125 milliliters, okay, we can't have all of that water go through and come out the bladder, okay? We got to get it back to the body. So these other ones, they're going to help with moving the water back to the system, to the body. Calcium. The hope is that not a lot of calcium gets urinated out. If you remember, the body is going to very tightly regulate calcium. We're either going to store it in bone or we're going to break it down out of bone. Very little should make it into the actual urine. The body is using other mechanisms to control calcium. For example, the parathyroid hormone, okay? Because calcium, the fluctuation in the calcium levels of the blood, it can only go a short fluctuation. The body cannot handle huge fluctuations in calcium. It'll kill you. Now the glucose, the sugars. With the glucose likes to follow sodium. So if sodium gets to move, a glucose goes with it. Now remember, sodium is having to be moved through these little transport proteins. But as those transport proteins work, when a sodium gets to move, so does a glucose. There should be no glucose in your urine. If it is, that's indicative of diabetes. All right? So that should not make it to urine at all. Then our nitrogen waste. Hopefully the urea passes with the water. And which way does the water get to go? We get to go between the cells. Hold up. What? Urea, nitrogen waste. We don't want it building up in the blood, right? Okay, so with the nitrogen waste, about half in the blood is removed. Now, almost all the uric acid is removed. Why would I be returning any of this to the body? It can, because it can be, because see right now, we're only in the proximal convoluted tubule. We still have this nephron loop, the distal convoluted tubule, and the collecting duct. Is everybody following me? So at this point, where we have urine formation 1 up to, the biggest goal is to take that huge amount of filtrate and reduce it down and get those electrolytes back to the body. So this is the major goal for the urine formation 2.